A meteorite could vaporize an area the size of a small country in less than a second, and yet the whirlpool from the movies would never actually form. That single fact unravels almost everything Hollywood has taught us about ocean impacts, and the real story underneath it is stranger and more violent than any spinning vortex. Start with the object itself. To make a splash that matters on a planetary scale, we're not talking about a car-sized rock. We need something like the Chicxulub impactor, the asteroid that ended the age of dinosaurs 66 million years ago. That object was roughly 10 to 15 kilometers across, and when it hit shallow water off the coast of Mexico, it slammed in at somewhere around 20 kilometers per second, about 60 times the speed of a rifle bullet. At that velocity, physics stops behaving the way our intuition expects. The asteroid does not splash into the ocean like a stone into a pond. It punches through the water almost instantly, because water simply cannot get out of the way fast enough. In the first fraction of a second, the impact site behaves more like a liquid and less like solid rock, with both water and crust briefly flowing under the sheer force of the collision. Here is the first mechanism worth understanding: the crater. Chicxulub's impact carved out a hole in the Earth's crust nearly 200 kilometers wide and initially over 30 kilometers deep, a wound punched clean through the ocean floor and into the mantle rock beneath. The energy released has been estimated at around 100 million megatons of TNT equivalent, which is something like 1 billion times more powerful than the atomic bomb dropped on Hiroshima. Within seconds, that much energy does not create a gentle draining whirlpool. It creates a wall of superheated plasma and vaporized rock blasting upward, along with a curtain of water violently displaced outward in every direction. That displacement is the second mechanism, and it is where the real tsunami begins. Water does not need to spin to become deadly. It needs to be pushed. Researchers modeling Chicxulub estimate the initial wave near the impact site may have risen over a kilometer high, a wall of ocean taller than most skyscrapers, moving outward at speeds rivaling a jet airliner. As this wave spreads across open ocean, it behaves according to the same physics as a normal tsunami, just amplified to almost unimaginable scale. In deep water, the wave is fast and low, sometimes just a meter or two high, nearly invisible from a ship deck. But tsunamis are not really about height in open water. They are about the entire water column, from surface to seafloor, moving as one mass. As that mass reaches shallower coastal waters, it slows down, and all that energy has nowhere to go but up. The wave steepens, sometimes into a wall of water tens of meters tall, and it slams into coastlines with the force of the entire ocean behind it. Evidence for this isn't speculation. Geologists have found chaotic layers of jumbled sand, shell fragments, and displaced sediment as far away as the present-day United States, deposits consistent with tsunami waves reaching hundreds of meters high near ground zero and still tens of meters high thousands of kilometers away. Some studies suggest the Chicxulub tsunami was, by a wide margin, the largest wave event in Earth's geological history, dwarfing anything triggered by earthquakes or volcanic collapse in the time since. Now to the whirlpool question, because this is where the myth needs correcting. A whirlpool needs a sustained rotational current, something like water draining through a narrow opening, the way a bathtub drain works, or the way tidal currents squeeze through narrow straits like the Maelstrom off Norway. An asteroid impact does not create a drain. It creates an explosion. The crater fills back in almost immediately, within minutes to hours, as ocean water rushes back toward the impact site from all directions at once, colliding chaotically rather than spiraling neatly. Picture slamming your fist into a bathtub instead of pulling the plug. You get splashing, violent churn, and outward waves, not a spinning vortex pulling toys down a drain. So the dramatic image of ships being sucked into a swirling abyss is, unfortunately for storytellers, not physically accurate. What actually happens is arguably scarier. A temporary crater filled with boiling, radioactive, debris-laden water, surrounded by return currents so violent they could tear a modern steel-hulled ship apart from turb.